All right, so let's start our class today. Okay, so this is lecture 5, and we will focus on classification. Right, so before I start discussing classification, I just have a short discussion with you on CA1. So as you know here, the deadline for CA1 is September 30th. So I wrote here is a tentative deadline. And I guess this one is after recess week. So recess week is from Saturday 17 until Saturday 25th. And a week after that is this deadline of CA1. It's on Friday at 5 p.m. Any objection on this? Any objection?
What's the date?
That one. It's Friday. Then it will be finalized. Okay, so the deadline will be fixed on September 30th at 5 p.m. Yes, of course. So the thing is that still more to come. So classification will be included. So today classification, and next week also classification. So today discussion and next week discussion will be included in part 5. Part 4 and 5, I think. Yeah.
So you have the last part 1 week before the exam, right?
1 week before the exam.
Yeah, so 1 week before the exam.
Oh yes, 1 week before the exam.
So you will spend time doing the exam, also doing the home.
Thanks for 2 questions.
That's the case. I think we need one more week, just in case. So we spend time in the studying the exam instead of doing the homework.
Yeah. So there is a request here. There is an extension for 1 week. So that will be October the 6th. Now, October the 6th. Any objection on this? I noticed that many of you is actually taking another course, which is visual computing, which is EE 571. And that one, the deadline is October the 8th. quite heavy, heavier than this. So I'm worried that those who are taking visual computing course will complain. So what would be the best solution here? Well, that will make your CA2 for this course. I'm not sure if you have CA2. You don't have CA2 because for those that majority here, you're taking the second part of this course, and they have the almost CA, and CA2 will be coming along the way. So yeah, in very difficult situation, to be honest, I can make the announcement of the completion of this part sooner. Even next week, I can give all the parts. Next week is already last one, right? So at the end of this weekend or the weekend, I can write all the parts, including the one that I will teach next week.
But we will have the question before the material, so we will not be able to solve it. So we have to wait for the next class to get that.
That's fine. That's the problem. Yes. So in any way, it's very difficult. It's very fine. But I think, let's see, we can either make it earlier than this,
Or make it simpler.
and make it simpler. But the thing is that if you don't do it in your programming, you will not be able to know what is the things going on. And that in terms of education is not really good. We just talk about theory and we do not know how to implement it. And that is like an abstract theory. That's the problem that we have here. We don't have this TA for our discussion. So I think you will be fine. 1 week learning process for preparing for the exam will be okay. So for 5027, I try to accommodate, but the situation is different. Now, okay, any question for this CA1? Any questions that you have in mind? Of course, if it is the solution, I can answer that. If you have any problem with this GA, please talk with the GA, with the graduate assistant. All right. Okay, any questions here for CA? Right. So if there is no question about the CA, let's move on for the discussion on exam for EE 5027 students. Today I announced the exam venue, the exam time, and so on. Now, are there any questions regarding the exam for EE 5027? Yes. It is multiple responses. Yes. The person are multiple responses. Well, if it's tricky, the hour is 19 minutes, 1.5. By the way, this is having to do with those 5 now. The other side. So there are two courses here. One is statistical pattern recognition, and the other is pattern recognition. So I'm talking here is statistical pattern recognition. So the answers here is only applies to statistical pattern recognition. Okay, so please keep it in mind. Yeah, so for that one is the duration is 1.5 hours. And how many? I'm not looking at it allow to give you the information. But the rule is that multiple responses A, B, C, D, and you have to write down the letters. A, for example, is true or A is false. Okay, so because this multiple responses, right? The only answer that you can do is true or false for each of the choices. But aside from true and false for each of the letters, A, B, C, D, you have to justify. You have to write down what is your justification. It's not just writing A, B, C, D, true and false, but you need to write your justification. Without justification, or if you give wrong justification, the mark is zero. Yeah. Okay, so be careful with that. Of course, zero means I will tolerate if you somehow half wrong, half right, I will give you some points. But my point then is that the justifications are important. Okay, it's not just true and false for each of the choices, but you need to give justification as much as you can. Now, that's a tricky part because writing justification for each of these choices will take time.
You have to write this for each.
For each, even though it's false, you have to write the justification. If it's true, of course, you have to make a justification as well. Okay? So that's the tricky part, but I can say that the time will be enough. So you can imagine if I give you 10 questions, means that each question will have 4 things to explain, to justify. So in this 10, then it will be 40 statements that you have to justify. Is that understandable? So even 40 for 1.5 hours will occupy you quite a lot. So that's the range. You can imagine it. Right? Yes, a good question. Any other questions? By the way, even for the other one, for the pattern recognition, the question might be similar to the statistical pattern recognition. Okay, we haven't decided yet, but it's likely to be multiple responses with justification. Further announcement will be given for pattern recognition module. Yes,
This is always for choices.
it is 4 choices.
You don't have to complete.
There is no more than 4. There is no more than 4.
And if the 4 choices, only one is true, or it could be
Multiple responses. Multiple responses, yes. Any other questions? You are allowed to bring 1 sheet of A4 paper. You can write whatever you want on this A4 paper, both sides. And this also applies to
can be 5 or only 100%.
up to you. You can do anything as well. Any other questions? If I'm not mistaken, for pattern recognition, which is the method that we're using here, the duration will be 2 hours, if I'm not mistaken. The further one will be sent to you. But for this one, for statistical pattern recognition, it will only 1.5 hours. Yeah. Sorry? Yeah, the same. Only 1 sheet of paper. Yeah. There is 2 differences here. The level is different. The grade is given to you and the other student participant. Right. Any other questions?
When you the 2 hours testing for it may end on this semester, right?
For you, for pattern recognition, it will be the end. There is no midterm. There is no midterm exam for pattern recognition. Any other questions? So the rule of the time and the cheat sheet are the same as last year. Or the same as previous year. Okay, anyway, so if there is no question, let's move on to classification topic. So I mentioned that the classification in last week's class is that we want to do something like this. So this is called classification, basically. And we want to find a line or a hyperplane or plane to separate the positive and negative. Now, if we have something that is not linear, so if you have something that is not linear, something like this, what do you do if it is something that is not linear? Exactly, increase the dimension of the space. So hopefully by, well, if you increase the dimension into very large dimension, you will always find a hyperplane. And that's the problem of fitting in classification. Okay. In that case, if you find very precise, even though there is noise, for example, the noise is here, for example, or the noise is somehow here, then it will be somehow into that part of the positive. Although that actually this one is or suffers from noise, means that the location is not there actually. Okay, so this can be solved by transforming this into higher space. So I will let you know later on how we can transform this into higher space. Basically, the transformation is something that we have learned is using basis function. So that's how you transform this into a higher space. But we will get into the details later on. And the most important things in this respect to solve this problem is data modeling. So data modeling is the first step in machine learning analysis or data analysis, and you have to know how to do it. Right? So anyway, so the data modeling that we want, as I mentioned last week, is that we have y. Imagine that you have xn. So xn refers to any point here. So that one is xn, any sample. And what we want is that we want to have this as W0 plus G equals to 1 up to G, X and G. Right? So X and G here, or I will write down here, it's the same thing as W transpose X and bar. And in this case, X and bar is what? What is the first element of the X bar vector? Anyone? Yes, 1. And followed by X and 1. So X and 1 here refers to this axis. And then we have X and 2, and X and 2 refers to that axis. Okay? And then we have another dimensionality. If it's 3 dimensions, is equal to Z. If it is a 4 dimensions, it will be another axis. And so on and so forth until we have X and capital T. So this is the vector of Xn. And in this case, actually this is T plus 1 by 1. But for simplicity, I just write T by 1. But you know the meaning of that. It should be T plus 1 by 1. Okay, any questions so far? All right, so if there is no questions, now what we need to do, we need to know the geometry of, basically we want to have this line, right? In the end of the day, if this 2-dimensional space, we want to have this line there. So the line is very important. And we want to know the geometry of this line with respect the geometry of the equation here, the geometry of this y xn with respect to the line that we draw, with respect to the red line. So what is the meaning of this, right? So imagine most of the cases, it is a binary classification. Binary classification means that we only have 2 classes. And in this case, the label of the classes can be represented by Tn. So Tn is your label. And Tn can be either 0 or 1 because this is binary. Okay, so 0 means plus 1, and 1 means plus 2, or whatever you want to name it. Okay, so it is a 0 and 1 label. As we know, as much as we want to have Tn the same as Yn. Although this is not true in our next discussion, but let's stick with this first for the sake of our current discussion. So Tn or Yn should be as close as possible to the Tn. Tn is again our label. So because of this, we want to know what is the meaning when Yn equals to 0. So the possibility of the value of Yn becomes, there are two possibilities. One is 0 and the other is 1. Okay? So in other words, we have, for the first case, we have Yn equals to 0. It means that y, x, and bar, which is w transpose xn, equals to 0. Any questions here? Again, if you don't understand, please ask. Okay, so I assume that you understand this. So what is the meaning of this? That's the question, right? It means that it's very simple. We discussed it before. For example, if it's R2, R2 means two-dimensional space. If it's R2, then we have y, x, and bar equals to w0 plus. Now the dimensionality is 2, right? So d here equals to 2. D equals to 1, W, D, X, and D. In other words, we will have W0 plus W1, X, and 1 plus W2, X, and 2 equals to 0. That means what? It means what? If we have a point, xn is a point, right? So again, just imagine that this xn here, it refers to a point here, a sample. And sample has a value, right? And that's the contents of xn bar. The location in the x-axis or x1 and the location in x2. Right? So that's xn bar. Now, if xn with respect to this equation equals to 0, what does it mean by that? W bar of 0. No. You know, this is the equation of what? What equation is it? It's a line equation, that's correct. A line equation. So there should be a line in this space, right? In the space that I draw, there must be a line. So now the question is that where is the line? Where is the line? Intersecting 0. Is that correct? That the line intersecting here? No. Where is the line then? Exactly. The line intersects with the point because it equals to 0. So there's a line. We do not know whether this line like this or the line like that. We do not know, but we know that the line intersects with xn because when you input xn, when you put xn here, the value of xn, it will be giving you 0. So you have to find W1, W0, W2 in such a way when you have xn, that xn, the sample point xn, it will give you 0. That's the meaning of this equation. So it is the same as if you compute with that, it's simply like 8x plus by plus c equals to 0. Right? And x and y and c is actually c is something so x and y, I mean, so if for example take a simple case, x equals to 2, y equals to 2, then x equals to 2, y equals to 2, right? So in that case, have to equal to 0 means that the line intersects the sample point. Any questions here? Any question, anyone? No? Okay, so, right, so that is the case when yn equal to 0. Now, that one is actually that one, yn equal to 0. The second case is that we also have yn equals to 1. So what does it, what's the meaning of yn equals to 1? Okay, so let's dig deeper. If you don't understand yn equals to 0, passing the sample point is fine. I will explain further, so then hopefully you can see. So now, let's say we have a point or a space first here, R2, and we have 2 points, and call this XA, and this one is XB. And previously we know that if there is a line passing through these 2 points, it means that we have yxa equal to yxb equals to 0. Okay. Now consider a case that there is another point which is called xc. And this xc have a closest distance to the line. And what is the closest distance to the line? How we can draw a line that is the closest distance to xc? What is the property of the line? It's perpendicular to the red line, right? So it must be perpendicular to the red line. Okay, so first of all, let's look at this equation. Let's follow this equation first. So in this case, yxa minus yxb equals to what? Equals to 0. Yeah. And the definition of y is what? What is the definition of function y? W transpose xa. In this case, it will be xa bar minus xb bar equals to 0. Agree with me? Right? Okay, good. Let me think. Okay, so there are 2 components here in this equation. So there are 2 things here, W and X, this segment. This is a line segment, right? And recall, if we have A transpose B, it's nothing to do with XA and XB. I just create a new variables called A and B vectors. And this A and B in this operation, A transpose B. In this case, if I can write in the dot product of A dot product B. They are the same thing, right? Did you see that it's the same thing? Who don't understand this? Okay, so they are the same thing. It means that what is the definition of A dot B? What is the definition of A dot product B? Yeah, that one is one definition. So this one is one A1 plus B, A1 multiplied by B1 plus A2 multiplied by B2, and so on and so forth, right? That's one definition. What is another definition of this? Oh, by the way, if I write that in that way, it means that A1, A2 until AN, for example, and B bar is to be B1, B2 until BN, for example. All right? So what is another definition of of dot product. Not submission. B, the magnitude of A multiplied by the magnitude of A multiplied by the magnitude of B cosine theta. This is the definition of dot product. We learned this in high school, right? Yeah. So it's a simple equation. Okay, so now if this one A transpose B equals to 0, because this one in for our equation there, actually we have this case that we have a case when one vector multiplied by another vector equal to 0. So now we have A transpose B equal to 0, right? So now the question is, what is the value of theta? Assume that the magnitude of A and B is equally 1, right? You can assume that. And then cos theta equals to 0. What is cos theta equal to 0? What will be theta? This is also even junior high school, I think, right? It's 90, very fine. It's 90 degrees. Right? If it is 90 degrees, cosine 90 degrees equals to 0. In other words, so this equation has some property, has some geometrical property. A and B line segment means that we are dealing with this line segment here. This line segment. That line segment is XA minus XB. Right? This line segment is the same as that one. Now, where is W then? Where is W in this case? So where is W in this one? In the diagram, in the drawing. It's perpendicular to the line. We do not know where is the direction. It can go up and it can go down, but it doesn't really matter, but it has to be perpendicular to this line. So we know that this one should be perpendicular. Well, W should be perpendicular. So W has to be perpendicular. So this is the direction of W bar. It's perpendicular to the red line. Any questions here? Right. So next is that XC is not on the line. So XC, why XC? Because XC is not in the line, then y of XC will not be equal to 0. Right? Okay, so now we want to know what is this value here? What is the meaning of this? What is the meaning? If it is not 0, what is the meaning of this, right? So what is the meaning of this? The question is that. Okay, so if we want to know about XC with respect to the red line, then we know that XC bar equals to XC prime plus W bar divided by W bar magnitude. So what it means by this, it means that there should be XC prime, and XC prime is on the line. So let me enlarge this one here. So there must be some XC prime. So XC prime is here. The blue dot, right, on the line, on the red line, which is the projection of XC bar on the line. And if you want to describe XC, then we know that xc, because it is perpendicular, the same as w, means that the direction will be the direction of the w. Right? And the direction of w is represented by this expression here. That is the direction of w in a unit vector. Now this is a unit vector, right? Unit vector of w. We don't care about the magnitude of the length w, but we just care about the direction of w. So that's the direction of w, but we do not know the distance. So to extract the distance, we just multiply this with certain constant r. So r is the distance of this to the projection of the point hc and hc bar. Any questions here? All right, so we can have that expression now. So that's for yxt, but we want to ask what is y of xt. So what do we want to ask is y of xt bar. So in this case, as usual, we know that the definition of the definition of y is w transpose multiplied by xt. This one is multiplied by xt bar. All right. So in this case, w transpose multiplied by xc prime plus w bar divided by magnitude of w bar multiplied by r. Any questions here? Yes.
So you're saying at the beginning that direction of W bar doesn't matter, it goes up or down.
Yeah.
But now you're multiplying, you're adding the units. So what's the case of the bar?
Well, w bar can be in any direction, can be negative. It's not necessarily positive. So the negative and the positive value of w bar represented the direction. Two questions. And r is not necessarily positive. It can be negative. You do not know r, but it's a scalar value. Yeah, good point. Any other questions? Okay, good. So now let's continue this one. It means that w transpose multiplied by xc prime plus w transpose multiplied by w bar divided by w bar magnitude multiplied by r. An easy derivation, right? We just put w transpose inside that parenthesis. So now, what is the meaning of that? What is the value of that? 0. So this one is 0 because it is on the line. Now, if that's 0, then this one means that it is equal to r multiplied by w transpose w divided by the magnitude of w. So now the question is, what is this? What is w transpose w? W transpose w means w dot product w, right? That's the same thing. And w product of w dot product of w equals to the magnitude of w multiplied by the magnitude of w multiplied by cosine. Yeah, theta here is equal to 0 because they are the same direction, the same entity. So what is cosine 0? 1. So we just remove it. So what happened then? What happened then? It's equal to r multiplied by the magnitude of w bar. So that's it. That's the meaning of yxt. Yxt in the end give you a distance. Will it be square? Yeah.
W multiplied by the magnitude of W.
That's right. But you have, yeah. So that's our W bar. So W bar is a direction, it's a unit vector, it's well, not sorry, it's not unit vector, it's magnitude of your W. And we do not know the magnitude of W, it can be 1, it can be 1.2, it can be 10. We do not know the magnitude of W. But that one is just, it's like the set. You know, your feet have its own instant, right? Has its own unit. So this is the maximum unit at our time. So if I keep walking in this way, right, that would be 3 r equal to 3 in my set. But it will be different from your set. So W bar here is the magnitude of that certain W. And R here, the value R depends on that magnitude. Is that understandable? R becomes relative distance. It's not an absolute distance. Because it depends on W by magnitude. Any questions here for the geometrical meaning of this? Now, we know that if, now we can define that if y xc bar equals to 1, because we only have 1 and 0 in the end, right? Not in the end, but in here, we assume, for now, we assume that this 1 is 0 and 1, then yn equals to 1 is something that we want to know the meaning of that, the geometrical meaning of that. So, and that one means that 1 equals to r multiplied by the magnitude of W. And in this case, as a result of this, R equals to 1 divided by W bar magnitude of W. That's when y of xc equals to 1. Y of xc equals to 1, well, basically, R will be depends on the magnitude of W. It means that there is some distance between the line and the point. Any questions here? So if this is the same thing, if R equals to 0 divided by W, for example, if the label is 0, then R equals to 0. Right? That's proof our statement that when it is on the line, well, when it is equal to 0, it is on the line because R equals to 0. But if it is not on the line, then it is greater than 0. Any questions? Yes. We will discuss that later. We actually don't use -1 our discussion. But if you read the book, there is a few techniques. One is called least square for classification, and there is an NLE and AT variation for classification. So I skipped the least square one. So I don't really explain to you the least square because we don't have time. And this least square, actually, you can set the label with either 0 or -1. Okay, so if you want to know about that, you read the textbook about least square classification. Okay. It is on the line. Yeah. I will explain later on to you how we use it in MLE. It is not for, well, it can be used also for least squares, but unfortunately we don't have time for that. I will explain how to use this equation for maximum likelihood MLE. Yeah, a good questions. Any other questions? Okay, so if there is no question, let's look at the real problem that we want to solve. The real problem that we want to solve is, of course, MLE for classification. So MLE for classification has another name. The name is logistic regression. It's a bit confusing. It's classification, but the name is regression. Right? So please be careful. It is actually classification, not regression. Right. So as usual, there are two steps here, two main stages in machine learning. One is training, and the other is testing. Okay, so first of all, let's discuss the testing side. So to make the discussion easier, let's focus on the testing stage first. So in the testing stage, what will be the input? What will be the input in the test stage? That's right. The data, which is x star or x new. What's the variable? X new is good. X new, right? And the parameters. The parameter is W bar. And the output will be, what will be the output? The predicted label, in this case, the classification label, right? Plus 0 or plus 1, or plus 1 or plus 2, 0 or 1. So we have T new, the label of X new, and T new is a set of 0 and 1. So either 0 or 1. And the goal here, of course, that we want to use a probability function of T new given X new W bar. Okay, so we want to know the probability of T new given that sample X new. So basically what it means by this is that we want to know whether P of T new equal to 0 given X new and W bar in relationship with P of T equals to 1 X new W bar. We want to know whether this one is what, right? Whether this is greater or smaller. So we want to know whether this is greater or smaller or equal in this case. If it is greater, then it means what? What will be the label? It is 0. If it is smaller, then it is 1 or 2. All right? Any questions so far? Okay, so the question here then, how can we model this? How can we model this probability? So the probability of T new either equal to 0 or 1 given X new and W bar have to be a probability function. This one has to be a probability function. Now, this is the difficult part of data analysis because you have to define a function, a probability function. And in this case, you cannot use Gaussian anymore, unfortunately, because you have to choose either 0 or 1. And Gaussian doesn't give you any of this choice of 0 and 1. So in that case, one of the functions that is suitable to our case, binary classification case, a sigmoid function. Sigmoid function is a probability function, and this one sigmoid of y x nu. So we know that y x nu from the previous discussion here. This is the definition of y x nu. It's give you an R multiplied by W bar, the magnitude of W bar. This one, right? That's the meaning of y, function y. So keep that in mind that y, I can write it down here for clarity. This one equals to sigmoid in the end R multiplied by W bar. We do not know, of course, W bar in this case, at this stage, but that's something that we want to, or we know actually in the question, we know W bar. And if we know the location of the line, then we of course can know the distance between the line and the triangle. But that's not the point that I want to say here. The point that I want to say here, this one is a scalar value. And what is sigmoid function? Sigmoid function means that we have y-axis, and then we have x-axis. And how does sigmoid function look like? It's letter, look like a letter of S. So letter S. Something like this is difficult. Something like this, but they are symmetric. And what is the point intersection here? The intersection point is 0.5. Okay, so that's the meaning of this function. And this one, the x-axis is what? What is the x-axis? X-axis represents anyone? Y n, yes, this one is y n, which is y of x nu. And this one, y x nu, remember that y x nu, well, now it's a bit different, so I will tell you later on. Let me see. So this one, obviously will be the y-axis is sigmoid of yn. And in this case, Tn will be here. So this one has to be equal or as close as possible to the n. So it's no longer yn that has to be the same as the n, but the sigmoid function of yn that has to be the same as the n. So it means what? It means that we have two regions here. One is this one, and the other is this one. So Tn or sigmoid equals to 1 if the value of the sigmoid is greater than 0.5. So if the sigmoid is greater than 0.5, it belongs to class 1. If the sigmoid is lower than 0.5, it belongs to class 0. Is it understandable here? Oh, by the way, what is the sigmoid function? Sigmoid of A equals to 1 over 1 plus exponential minus A. 1 minus, okay, maybe, this one minus? I think it's plus. And I don't feel that it's negative. It should be plus. Check in the Wikipedia. So it should be plus, I think. So that's the meaning of this. So your sigmoid function will be, if it is greater than 0.5, it will be 1, means that 1n is encouraged to be, if it is belongs to, if 1n belongs to, because two cases, right? Plus 0 and plus 1, plus 0 and plus 1. For plus 1, 1n is encouraged to be what? It's encouraged to be 1n is again is a scalar value, right? 1 is a scalar value. In the end of the day, 1n here is this one. It's a scalar value. And in this case, if the label is 1, your Tn is 1, Yn is encouraged to be large or small. Yn is encouraged to be large, of course. Because this is Yn, right? This one is Yn. So the further the Yn, the higher the value will be. The smallest Yn, if for example Yn equal to 0, what happens with sigma n? What happens with sigma n? 0.5. Exactly. What happened with 0.5? Yes, 0.5 is ambiguous. It's not 0, not 1. You cannot decide it is 0.5. Right? So Yn to have a more definite label, you have to push it as large as possible. So, in other words, if you look at the previous geometrical definition of positive, for example, positive sample in that direction, for example, and you happen to know your line, and you have negative on the other side, for example, right? You want to have this one as much as possible from them. So the distance of the positive to the line has to be as far away as possible. But on the other hand, if it is negative, you encourage what? If it is 0, if you want to have plus 0, Yn is encouraged to be very small, to be negative, large but negative. It means that if it is negative, you want to encourage them to be as far away from the line. So there are two forces here. From the positive point of view, I want the line to be as far away as possible from me. But from the negative plus point of view, it's also the same. This line has to be far away from me. So in the end, these two forces will collide. And the collision and the two forces will collide in the middle ground. So in the end of the day, the line will be in the middle between these two classes. Because it's encouraged by the sigmoid function. If you want to be definite close to 0 of the n, then you have to negative large value, plus negative value. And if it is equal to 1, if the n equals to 1, then it has to be as large as possible in the positive direction. And that's a consequence on this idea, on this encouragement, because in the end, the line that you want to draw, the line that you want to extract, will have to satisfy these two conditions. Does it make sense? Any questions here? Okay, if I'm not clear about any doubts, please ask. Any question, anyone? So this is the intuition behind the mathematical equation that we will discuss soon. It is not yet the derivation of the mathematics, but we will discuss this, how we can get a line in the middle of positive and negative plus. Okay, so if there is no question, let's move on to the training. So the training stage is of course to get the red line, right? Given the positive and the negative. So the training stage here, given the positive and the negative, positive and negative, you want to find the line. And we know the line must be in the middle of the positive and negative. So it will be in the middle of the positive and the negative because of the negative want to be far away and the positive also want to be far away. Right. So now let's look at this. Now the input for the training stage is what? Anyone? What will be the input of the training stage? The data in the label. Right. So this one is a set of xn bar tn n equals to 1 until n, capital N is the number of your sample. And the output is what? W bar. Yeah, so W bar refers to the line. Although to be complete, this one is be Y, and no, not Y n, but Y in the middle down there, right? Which is W on 4, X is somehow here, a point in that part, and this one equals to 0. So that W that you want to find. Okay. So remember the techniques that we use for this task is MLE. MLE means that we want to find the maximum of the likelihood. Maximum likelihood estimation. So in this case, you have to do the modeling, likelihood, data modeling. Right. So in this case, if you want to model likelihood, it will be P given, P of likelihood. Likelihood start from known. What is known? Xn and Tn. So in this case, Tn is taken. And given what? What is unknown? W bar, the line. Right? Okay, so in this case, the definition have two definitions as we discussed. One is that when P of Tn equals to 1, given W bar. In this case, it will be sigmoid of W bar, sigmoid of W bar transpose by n. Well, I stopped using the function here, but you mentioned that this also can be xn. Okay, so let's call this. Yeah, apologize for this one. I messed up with the variables. I hope that you are not confused, but I call this one yn. Is that confusing? Normally, I put yn equal to w transpose by n, right? This is a normal thing that I just normally use. But now, this whole thing becomes with yn because I want to make yn equal to tn. So if you confuse, please let me know. Now yn is the same as sigmoid, no longer this one. Anyway, so hopefully clear here. Anyway, so now that one is P, Tn equals to 1. What happened with P of Tn equal to 0, given W equals to, it is a binary, right? It means that I can describe that this one equals to 1 minus 1n. Because it's just binary. and the sum of this is equal to 1 because it's probability function. Okay, it's agreeable here, right? Right. So now the problem is that we have two equations describing one equation, one probability equation, one probability distribution. So this one basically refers to that. We have two equations. We have two equations describing one probability function, and it's a bit troublesome. So we want to combine them. We want to fuse them. And to fuse them, to make them one, we can write P of Tn given W bar equals to, this is a bit tricky, Yn power to Tn multiplied by 1 minus Yn multiplied by 1 minus Tn. Does it make sense? I think it makes sense, right? Because if Tn equals to 1, imagine that if Tn equals to 1, then this one equals to 1, this one equals to 0. And you see that power to 0 is 1. So you can ignore the second term. Now, if Tn equals to 0, the first term will be 1. Then the second term becomes, the power becomes 1, and then you can consider the second term. So it's a flip-flop thing. It's the same thing like the two equations that we did that above. Right? And this is the convenience of the mathematics when you can fix into one equation. So you can describe this P of the n given W in one equation. Any questions, anyone? Okay, so this one is for one data, And what happens if you have n data or n samples? And if you have n samples, means that we have P of T bar, because now we have many samples, given W bar equals to, now we describe this as independent between one sample and the other samples. So in this, if we assume that it's independent, then we can write in this way. Okay. Any questions here? Yeah.
How can we independent as time?
Because one point, for example, we assume that you have multiple points in your training set, positive here, negative there. So in this case, you assume that this sample and that sample are independent.
In reality,
of course, they are independent, because we assume in this case to make things simpler to be independent. Yes. In reality, of course, there is an underlying function for each of the samples, and that because the two samples depend on that underlying function, then that is not independent. But because it's too complicated, it is not independent. So let's focus on the independent case first to see how far we can go. In the next stage, when we talk about Bayesian sequence, we remove this independency. But for now, let's assume simple case first. Yeah, good question. Any other questions? Okay, so that's the modeling part of this MLE. Let's move on to the second step. What is the second step? After we do the modeling, error function. Yeah. Error function. So error function here, we want to find W in the end, W, the best of W value. And this one is our max, because we maximize the likelihood, right, of a W of the function that we have, which is T bar W bar. And in this case, we can make it simpler by arc mean, because we don't like max, of W bar of E W bar. E is your error function. What is E then? E W bar equals to minus log P times T times T bar W bar. Any confusion on this? Any questions on this? This is the thing that we did many times already. Well, if you confuse with this, let's remove this one. So, first of all, we don't max W bar. I can put log P of T bar W bar, right? Okay. Then because it's max, then I make it arc mean by multiplying with minus function minus log P of T bar W bar. So that's why this one is your E. Okay. Why we use log? It's to get rid of not the exponential function. Well, yes, to some extent, but that's not the main reason. The product, yes, the product. So because we have a product sign here, and we don't like this product sign. We like sum instead of product. And the log of product is sum. Okay, so in that case, we change the product, becomes sum, it is minus sum over, so the equation is complicated, is that one, this equation here, under the red box. So 1 and the n, so that one becomes, you can copy and paste, so then you can follow the derivation. Okay, so that's the P of T. And if you do the logarithmics, then what happens? What happens, anyone? What is the parenthesis? What is the next of the parenthesis? Log of yn power to Tn. Give you Tn multiplied by log yn, and then multiplication becomes summation plus and then the next item will be 1 minus Tn log 1 minus yn. And all right. Okay, so that is the equation that we also know that minus sum of n, Tn is just 1 or 0. So Tn is a scalar value, Tn is 1 or 0. And then log yn is a function, right? What is the function of yn? Yeah, that's the old one. The new one is sigmoid. Sigmoid of W transpose, yeah, xn of yn. Plus 1 minus Tn log 1 minus sigmoid W transpose yn. Any questions here? Any question, anyone? Okay, so be careful with this sigmoid n. I mentioned again this sigmoid n. Oh, yeah, sigmoid n is equal to sigmoid function of x nu or xn. And this is the basic function. It's exactly the same as the function that we learned. Oh, by the way, let's define this in case you do not know. What is the factors here? What is x, the dimension of xn first? What is the dimension of xn? D by 1, right? D by 1. Good. Now, what is the dimension of your basic function? Are you sure that it's the same as
M by 1.
it's m by 1? M by 1. So let's define that. The first item will be what? The first element here, 1. And then the second one is 5. 1, which is n, right? X and this one 5, 2, X and until 5 m or n and minus 1, right? X and so what is the difference between 5, 1 and 5, 2? What is the difference between 5, 1 and 5, 2? What is 5, 1 and 5, 2? Remember, this one is the support basis. So this one you can imagine is a support basis. This is and the mean is mu 1. The second one, which is this one, for example, it is mu 2. So that if I have m, how many bases that I will have? It will be m bases. So it will be up to m. Okay, that's a supporting basis. So your xn is split by 1. Right? But your phi make it into, so there's a transformation here of the data. So xn, for example, xn live in R2, xn bar live in R2, you can imagine that this one is something like this. This is xn bar. Now, if phi bar n lived in R3, means that d of m equals to 3. So what happened is, what happened with this? It is, this one is phi 1, phi 2, phi 3. This one is x1, x2. Maybe this one is x1, 2, right? So there is a point here in this space. That point, it is phi xn. That's what happened in your imagination. Then what does it mean by this? What is the implication of this? What is the implication of it? It means what? You transform your data into higher dimensionality. Yes. Yeah, that one is actually n minus 1. Yeah. I always forget the minus 1, so be careful. Yeah, so in this case, for example, imagine that x and actually 1, x and 1, x and 2. So this is a d by 1, but actually this is d plus 1 by 1. But this is two-dimensional space. The one there is actually only for the offset. Okay, so the same as the phi. Phi is the same in this case, phi n. Phi n in our example is actually 1, phi 1, phi 2, phi 3. This is actually 4 by 1, but we know that the space is actually 3 by 1. So that's why I call n equals to 3. Right? Yeah, good question. Yes. Oh yeah, it's up to you. It can be Gaussian, it can be sigmoid, it's up to you. It's nothing to do with the sigmoid function that we discussed before. It is the talking of basis here. So that is independent things. So you can use Gaussian here. But the Gaussian, it cannot be one-dimensional Gaussian, it cannot be univariate Gaussian. It has to be multivariate Gaussian because the input xn is now multiple oriented.
X and 1 also we count as 1 by m, right? M by 1.
So the correct way is n plus 1 by 1.
I mean, the X, so, the X and,
Xn, yes.
yeah, what's the dimension here, but X and one, for example, will be 1/m, right?
Xn1. So Xn1, okay, so I can explain this. So this one, right, refers to this.
Yeah, dimension zero, but
That one label. It's not dimension, this one is the axis. Yeah. So, yeah. So the same as phi 1 refers to the axis. Okay, any other questions? Yeah.
question, in this case, we made the dimensionality of the Xn bar less than the,
Yeah, this one is less.
but in the main benefit of basis function is that we reduce the d by 1, right? But sometimes we have a lot, well, at least maybe this is for the regression, because we have a d by 1, so we make this by n by 1.
So in regression,
Regression, we do have the Xn bar is
yeah.
n by 1, right?
Well, there is we're talking about something that's different here. Because remember that x, in that case, x polynomial. So x polynomial means that the complexity of the data is represented by x. But x here is no longer polynomial, it is representing the dimensionality of the data. So you have to separate these two. I know that it's a bit confusing, but in the regression, x and bar there represent the complexity of the model. How fast you want to draw your flow. But in this case classification, x and bar, the bar here, representing your data dimensionality. It's nothing to do with your model complexity anymore. It's nothing to do with model complexity.
So in this case, the choice basis function or classification is not going to reduce the computation.
Not at all. Not at all. So I will explain that later on. Yes.
X is X1 and X2 represent the features of
Yeah, the dimensions of the features. Yes, because they're not your features, two dimensional, three dimension, four dimension, that's the feature space on the features. Yeah, any other questions? Okay, if you have any doubts, please ask. Because we will base on this in the next discussion again. If you don't understand, you will get lost. Any other questions? Okay, so if there is no questions, so as you can see here, phi is very powerful in a way that it can transform one space, your data space, into something else, into higher space in this case. Right? So why do we want to do this? Why do we want to use phi to do this transformation here? To do this transformation here? Why do we need to have this transformation? Exactly. So in the beginning, I mentioned this, that in some cases, you have this kind of data, the complex classification. So in this complex classification, right, so in X dimensionality, of your X n bar, you have a case where positive and negative are non-linear. So this is non-linear. The red line is not linear. And you cannot do anything in this space. You cannot draw a straight line. Because straight line is impossible to separate these two. What can we do? Now, that's the key. That we transform this into higher space. Normally this one is x1 and x2. We transform this into phi 1, phi 2, and phi 3. And hopefully in this space, the positive and the negative can be separated with a plane. That's the reason why we want to have phi, to increase your dimensionality.
So if you want to add another dimension, you still can use phi, right?
Yes, you can choose a good question. You can choose phi or the dimension or n, the dimensionality of phi, as many as you want. It's not that there has to be 3. It can be 4 and 5 and 6 and 7. It's really up to you. You have freedom to set is number of n, the number of dashes, right? In other words, you can transform this further if you want into much higher space. Yeah, what is the consequences then? It will give you offer fitting situation. Why? Because even though there is a noise in your data, assume your data, this is the red line, the red circle is your true classification function, but your data, your training data has positive there. Right? So if you plot this into very dimensional space, there is always a line, there's always a line or plane that can interpret the positive and negative, and then you can project back again into the original space that you have. In that case, the line will be like this. And that's the overfitting problem for application. Because actually the green point is not the space for the positive. That's actually the space for the negative. But only because of noise, the positive go into the area of the negative. So that's why you have to be careful here in setting your M. And here is very powerful, but it can also give some consequences, negative consequences. Any questions here? Oh, by the way, it's not necessary that M have to be greater than D and greater than D. But M can be smaller than D if you want. But what will be the consequence of that? Underfitting, yes. So normally M is greater than D, your original space, or at least the same. Any question on this? Okay? Yes. If it is less than D, then well, I cannot imagine, right? So if you have positive and negative, you have positive and negative here, for example, in your exam, you have positive and negative. Why you want? Because in the end of the day, we want to have a line separating the positive and negative linearly, right? So I don't understand the logic why n has to be smaller than d and d can have solution. It doesn't help because if you reduce it into smaller dimensionality, for example, what happens if you put it into small dimensionality? What is the if it is less than 2, what is the dimensionality? One dimensionality is the only choice that you have, right? One dimensionality is a line and one axis. If you transform this into this one, into this, what happened then? What happened with your data? Positive is here, negative is here, positive, or not 2 dimensions. This is, I mean, 1 dimension. Positive is here, negative is there, negative is here, positive is there, right? It will be more difficult to separate. So if your original data is high, it is really good because there is a potential that you can separate. If you can separate in that dimension, it means that there is no linear function that can separate the data. In that case, most likely that we have to go to the higher space, not to go to the long space. Because long space make that complexity even more complexity of the structure of the liquid more complex. You can move from one liquid in a lower dimensional space. Yeah. Good question. Any other questions?
What if we receive the data that has already dimensions more than what we need to separate them in a line or plane? Should we use the dimension to make it easier to compute?
So, in some cases, that actually I give a wrong impression. I assume that the data is the data, some data have dimensionality that is not necessary. Other data have all the features that is needed. right? So A is offer excessive kind of features, and B is enough features. The feature is proper features. So for B, for proper features, you don't need to lower the dimensionality because that one will screw up the data. Right? But for A, because it's excessive features, there are so a lot of features that if not necessary, then you might need to reduce the dimensionality to find which one that you have to remove out. So yeah, that will be the answer for you. Because I assume B instead of A as well. Okay, any other questions? Yeah.
So the first part, A,
Yeah.
what happens when you do the last position and machine learning? Because we have a lot of features that give us like two key features that we
So for example, your stock price, right? Your stock price, it will depend on the, for example, government policy. Only the click on the line price is depending on the government policy. But the person that gives the data to you also put many other things like economic condition, like people mood, certain company trend, and so on. So many data that's necessary. In that case, if you use this one, it's too very complex and it's not necessary. Then you have to find the government policy features in this data. So that's why you have to reduce it. So then
I'm asking about the Python.
about
The Python, machine learning.
yeah.
So this is like the last regression. Last week.
Oh, that's so, yeah, that's so.
Last week is increasing the number of features that you want, just like.
Lasso is exactly the same as an AP. So there's a regularization to reduce the complexity. Yes, exactly. Yeah, Lasso is another name of NAP in our system. All right, any other questions? Okay, so if there is no question, let's move on. So now we are here actually, so that's the reason why we want to use phi instead of x. Okay, so again, I just want to emphasize that this one, phi, the concept of phi here is very important and you have to know. Okay, so you have to know that. Now, after we have the error function, E is the error function, what will be the next step? Number 3, optimization or implicit minimization. So what is the basic concept of minimization? This is the simplest from the 3 steps. What is the basic idea? If I want to write it down in the equation, the derivative of E with respect to W bar equals to 0. Yeah, this is the simplest among the 3 steps. The first step is the hardest because you have to do the modeling. Okay, so in this case, we have to minimize, we have to do the derivative. It means that we have minus sum over n d dw bar for all these equations here, for the whole equation there. All right, and this one equal to 0. Well, this one is a bit complicated to do, especially, well, the Tn is independent, but this one is actually not dependent. This is still W. This one is still W. So we have to do the derivative with respect to the sigmoid. The derivative of sigmoid is sigmoid multiplied by sigmoid minus 1. So I will not get into this one. If you want to know the details, you can look at the lecture note. So in the end of the day, I can tell you that dE dW bar equals to, which is the gradient of dW bar, is the same thing, equals to sum of n
phi W transpose phi n multiplied by phi, sorry, it must be Tn here, minus Tn multiplied by phi n equals to 0. So in the end of the day, what kind of equation that we want to have? What is the variable that we want to find here? Which variable that we want to find? W. So this one is the important thing, right? So, so this one is the most important thing. W is there, but yeah, W is there only. Yeah, that's only W. But the problem is that sigmoid is non-linear function. Remember that sigmoid is 1 over 1 plus exponential function of minus a, right? And a here is W. So this one is actually W minus W transpose phi xn. So W is actually inside the exponential function, which is very complicated to find out. So in other words, we cannot form a function where W equals to some function. We cannot form this kind of closed form equation. Right? So if we cannot find a closed form equation to get our variable, what will be the solution? Sorry? No, this is a fact that has been invented 400 years ago by someone called Newton. So Newton already solved this problem. Well, the solution is called Newton method. It's the same as the basic principle of Newton method is the same as gradient descent. So the solution will use, because the function is so complicated, then you have to use gradient descent. Or in this case, we just use a better version of, I can write gradient descent. So this is gradient descent. So I can give you a simple case, gradient descent. If you want to have W bar, we have to set W bar nu, or maybe if nu we already use nu. So let's use T or K or whatever variable, right? T is better, I think, but it's nothing to do with Tn. It's T time, right? It's K. K, yeah, K is better. K. Oh. W K plus 1 equals to what? WK minus, because it's descent, right? Descending, it has to be minus theta or eta, which is the learning rate, or alpha is easier to write. Alpha is the learning rate multiplied by T E T W when W equals to WK. That's called gradient descent. And this gradient descent, what is the requirement that you have to have? Alpha and yeah, so there are two requirements, this and that one. And that one is exactly the same as this. Already, we have got that already. Correct? Agree with this? Right. So how to define alpha? How we can define the learning rate? Sorry. Yeah, that's a good. I will discuss that later. But I will say something about alpha. Alpha, how do we define alpha? So what is alpha in? So learning rate. So if I have E of W, and I have W here, multiple dimensionality, but I reduce it into one. And then you have a function. It's not negative, by the way. It's not negative. All right. So this is your function E. Basically, this is your function E of W. It's very complex function. The goal is what? What is the goal here? The lowest point here. And this one is your W star. And we try to avoid local minimum. So this one is something that you need to avoid. But anyway, so that's something that referring to the comments that there is an initial value, because in the beginning you have to have k equal to 0, right? And that for k equal to 0, what do you need to do? What is the W in the beginning? Yeah, how do you use W? Oh, by the way, this is part of the assignment. So you have to pay attention on this. It's a really important assignment because you have to do the utilization of the W. So how do you initialize the W? Well, actually random. In the Gaussian descent, you have to do it randomly. So you have to do it randomly. And if you are unlucky, if you're in a bad luck, then you will have a situation where your initialization value is 10. So this is your W. If that's your W init or W init is W k equal to 0, right? Then you will be trapped because you go that way and then you get trapped into that local minimum. So be careful with your initialization. So the best initialization is somewhere here. W init to be this. That will be safe for you because now you can descend into global minimum. Now, again, I back into the question of alpha. What is the meaning of alpha in this diagram? The stick, yes, or the how fast the ball rolling, right? So in one step, what is the step of the ball rolling? So if it is alpha into it's small, for example, it's very small, 0.001, for example, that step will be very small. So there's one step, second step, third step, fourth step. What is the problem with this?
Very slow.
Very slow. You will have to wait a few minutes in your case, or a few hours if your alpha is very small. Now, why not we just make it big? The step big step, alpha big, 10, 100%. It will overshoot. Yeah, it will overshoot that one. If it overshoot that one, what happens then? It will oscillate. That's right. It will oscillate. It will oscillate all the time. If it oscillates all the time, then you'll never reach the global minimum. So this is the danger of gradient descent. You have to deal with alpha, and you do not know how to set alpha, the learning rate. Yeah.
How about the initial? How do you know that you are in the right?
We do not know, unfortunately. So what you can do is try to a few initialization and see which one is the lowest. That's an unfortunate thing that you have to deal with.
What if your two initialization happen to be in the same site? On the
Well, you are unlucky. You're really unlucky, actually. Someone use not just 2 but 3 or maybe 5 times, and you are unlucky that you get the same value. Then yeah. Okay. Any other questions? Okay. So if there is no question, as I mentioned, the problem of gradient descent is alpha. It is setting alpha. It's too small, too slow. If it's too high, it will be overshoot and oscillate. So now, what is the solution then?
make the learning rate.
Yeah, to change this learning rate. And what is how to change the learning rate? Second derivative, exactly. And that is called, the name of that is called Newton's method because it's found by Newton. So Newton, the guy, the English guy, called Newton, right? So he thought already about this, and his solution is that you need to find this alpha using the second derivative. So alpha is the inverse derivative. So the inverse of the second derivative is square e dw bar square. So he defined it that way. It is the tangent, the direction of your tangent, the direction of your stick. So it's like an arrow. So you know where is your stick, and then you put arrow in, and then release the arrow. So it means like it is in this place, for example. If it's in this place, then your arrow is somehow like that. It immediately go up to that location. In the second iteration, it will be this arrow in that direction. So that's why it makes the computation very fast. Right? Because it's just going through that direction immediately. It's nothing set by human. So that's why this is quite powerful Newton method. Right. Now, what is the problem here? Why Newton method has a problem here? What is the main problem? If you look at the mathematical equations, what is the main problem? Well, it's fine. We can do if you have the first derivative there, to get the second derivative is easy, right? Right? There is a certain condition that it breaks down. No, that one. There's a very fundamental mathematical equation here. It's only three. It's converged. Yes, not alpha equals to 0, but alpha is infinity. When is that an alpha infinity or in undefined? When this one equal to 0. When you cannot, or of course, it's the same, you cannot do the second derivative. The second derivative equally lead you to, because the second derivative is an assumption when W equals to WK. And that can make u equal to 0. And if it's equal to 0, you cannot do anything. Right? So that's the danger of this. In our case, because we are dealing with factors, so it will be W mu or WK equals to WK minus 1 minus, if it is a factor, what is the second derivative of a factor? What is the second derivative of a factor? W is the first derivative is called Jacobian. The second derivative is Hessian. Yeah. Hessian is 1 over Hessian nabla e, which is the first derivative. Okay. So nabla e is the first derivative. H is the first derivative. But we cannot write it in this way because H is a matrix. There is no 1 over H. There is no 1 over matrix. So what is the inverse of matrix? Yeah, inverse of matrix. So this one has the inverse of matrix. So that's the same thing. H, or in the previous discussion where we said that the second derivative equals to 0, then it doesn't make sense. In this case, H inverse can be non-invertible. And when it is non-invertible, well, one of the things is that when it is a singular matrix. If it is singular matrix, then it is not invertible. Okay. And that's the same problem that we have previously, that when the derivative or second derivative is 0. And this is again called Newton methods. And H here, as I mentioned again, is the second derivative of your t. So this is the derivative of W of T, E, T, W. And we know this already. Okay? So this is something that you have to compute as well in your assignment. The second derivative. And you can do this for a few iterations to get the result. You have to execute your program a few iterations to get the result. And if you plot this, it will give you a separating line between the positive and the negative. Any questions, anyone? Let's see if I can give you the example of this. Okay, so let me see if I can show this to you. So basically, this is the next assignment. Right. So this is something that you will do. So given the data like this, then you are supposed to find a line that separating the blue and the red using the method that we just discussed today, using MLE. Right. So basically, this is the task. And hopefully, we can get the point when we separate with this kind of graph. So this one using Bayesian approach, using predictive distributions. Anyway, so yeah, so this is the assignment that you will have to do the separation between the blue and the red. Okay, any questions so far? So if there is no question, let's have a break, right? And then we start again at 5 minutes past 8. So 8:05. Yeah. So. Previously, we have P E T W bar equal to this, right? And this one, the definition of this is with another way to divide it.
Assignments to, oh, well, I wonder, well, the meaning of sequential learning is that, first I have 3 points, and I want to calculate the W. And then if I could get more points, like 4 points,
Yes.
and I could, update,
Update after the system, yes,
and
one by one.
I could get a more useful value.
The W will evolve. W will change. Yeah.
And well, in C1 of the first question, I have to predict the value.
Yeah.
Well, I'm a little confused about, well, if we should make the prediction, firstly, we should calculate the parts using this function, and we could get the as in C1. Firstly, I use the 1 point to finally the all 50 points. So I could update the S and one by one.
One by one, yes.
And
so when the data comes, you update the W, like in sequential learning.
So by firstly, I could get 1 point and I could get S and M.
Yeah.
And then I could use this S and M
To predict all of them.
To calculate this.
To calculate all of the data. So you assume that so example, you have 10 data. In total, you have 10 data. But the data first come is only 1.
Yes.
Right? So this one is your training data. And your 9 remaining data are your test data.
Oh. So well, the pictures in the C1 like, well, data for example, I could get this point.
Yeah.
And I should predict all of this
Based on the
first
one.
point.
Yes.
I should predict the
49.
49.
Yeah.
And as well, the
training data is only 1.
I should predict its range. Like,
yeah,
this is the mean, and that is
the range,
mean
the
plus
covariance.
derivative.
Yeah.
And I have another question that I'm a little confused about this formula.
Yeah.
Well, firstly, I could calculate this one. Well, the dimensionality of this is multiply 1 and multiply n.
Yeah.
Yes, but well, I'm a little confused about what's this and no. Well, that's exactly the
Previous one.
the previous one, and I'm a little confused about this is the
Current one. The basis function of the current data.
basis. Well, as we calculated before, the basis, I could get the basis function as a matrix, right?
Well, in this case, a vector, because you only have 1 data. X bar is 1 data. X star is 1 data. So you only have a vector there.
So I just choose one row of the
Yeah, one by one.
one by
You calculate 1 by 1. So data 2, you compute this one. Data 3, you compute again. Data 4, you compute again.
and I finished the prediction.
49.
Okay.
I just want to ask you a
Yeah.
question.
Yeah.
So, in this case, for MVP.
Yeah.
Right, the alpha, sorry, the beta is actually the variance of the noise, right? Okay, but if you put it in this equation, how do you know the variance of the noise?
Yeah, so that's a good question. So you do not know unless you know if you look at your, well, observation, you can see how bad is your data, right? That's through observation.
Yeah, yeah.
Or you take some subset of the data and try to do the fitting and try to find the best fitting. Assuming that you change data all the time, then you can find the best fitting, right?
But that sounds very random, actually.
So that's called searching the fine-tuning the hyperparameters.
Okay, but for the assignment question you gave alpha, you didn't give beta.
Yeah, so that is something that you have to observe and try. There's no solution for that. Even now, it's still open problem.
Yeah.
So what can you do is try to a few different data, because you actually know. Because you know the data, you search the data, right?
Yep. So,
Although we assume that we do not know, of course, but the purpose of this assignment is, when you guess and it's wrong, what will happen with the curve fitting? So then you can learn that when you make a mistake,
okay.
then you can know what is going on there.
Oh, okay, I see. So it's still just like trial and error.
Yeah, it's right.
Yeah, I see. Okay, thank you.
I just use the instead of like because I think the police will the manager can be single file.
Oh, okay. Not the learning rate, but that one is Newton method already, right? So you can write in this way in the end. So W using transfer method, you can actually do the derivative further, and then you form this solution here. But this is something that you refer to? Yeah. So you can, but in the end, even for this one, for the simplest equation that I mentioned here, you don't really have an alpha anymore. You know, Hessian matrix.
According to the setting, the bridge itself because the error function can be
So this one is H, phi R5. You can get into this, use this direction directly, right?
what does this R
So R here is sigmoid. Sigmoid and I think it's that. You check again. Yeah, you check again. That's the R.
Now.
Yeah.
So talking about
Yeah.
So it's very kind of
Yeah. We have time. We get into that. And do multiple classes.
yeah, and the question is why it should be
Oh, because we have a second derivative. Because in the
because things we're solving for this equation, this is actually del E del W bar. This is del E del W.
yeah, the first derivative.
Yeah, I think the function is and considering supposing I think this should be the
Oh,
this is
so
function for trying to
no. So this one is Jacobi. Okay.
this is already
If it is in the factor form, it's Jacobian. But
yeah, but in this scenario it is
it is a factor form because this one is a physical factor.
yeah. But this would be a function, but normally any would be
This one is a good question. It's
yeah, this would be
one.
2 by 2 in this case.
This one is 2 by 2.
The dimension should be or normally 10 over 5.
So, but this one is because it's 2 dimension, second derivative, it is from the yeah. So you can search on Wikipedia on the definition of Hessian matrix.
Yeah. Do you think about neural possibility?
what stability? Numerical stability. What is the numerical stability? It is not stable. It's the inverse.
Yes.
Inverse.
So when it's compared, W bar is someone is close to the thing. And within a certain allowance.
Yeah.
For example, if I never get to that round, means number of growth.
Yeah, it can explode. It can, well, most of the time it will not explode. Most of the time, but there is a case, of course, it can explode when your error is getting bigger and bigger and bigger and bigger. But I think that one is relative. If you don't consider it. Yeah, so that's
So normally we just
yeah. This more, that one is more general.
this one is
This one is more general.
so actually
Yeah. Yes, yes, you don't need to do the second derivative yourself. You can just use that one if you. Okay. Yeah. Thank you.
I mean that somehow it appears where the concept. I don't have any particular point.
Can we discuss after the class? Because we already there and I haven't. Yeah. So when compared to different people, oh, cannot. The different features have to be different. Otherwise, it will be one feature. Yeah, in what axis so many yeah, but that's so many problems. And the lying circuit, the lying on how you think. Otherwise, if you force it, then it doesn't give you anything. Yeah, there will All right, so let's start our second session. Oh, by the way, before we start, I just wondering how many of you have ever looked at the textbook?
I really suggest that you look at the books, the textbook, because the textbook explains many different things there, and it has full page on the textbook. Yes.
There is one problem.
Yeah.
Flow, what time you jumping from one down to five.
I see.
Unless you can, please give us like one section that you can go.
Yeah, so it says that one is on the website. On the website, you can see this lecture, for example, this material that you can read. So you need to go into the website to see the corresponding section. Yes.
Now we rely on the textbook or the non.
Cool. So what is the exam material? The exam material goes for two classes. So this is the kind on this. The question in the final exam will be taken from the reading material. Okay, so from the reading material in the so this one, for example, there is reading material, there is additional resources. Okay, so the exam will be taken from the reading material here.
Even if the reading material is linking to Wikipedia and other things.
That means that you have to know about that subject. Because it's not mentioned, for example, in the textbook, but you need to know about that subject.
Like for example, basic calculus. I know everything inside.
Yeah, of course not. Of course not. So things are the, more or less the information there means that everything that we do in the second derivative of factors, for example, then that's usually part of the method calculus. So in that case, you have to know about how to do the derivative with respect to factors. Okay, so that's the fine grain there. But of course, I cannot make very specific in here. Right. Any other questions? Yes.
How about the slide? You have some slides.
That's right. So the slides, the slides supporting the lecture notes. So if you don't understand the slide, I think it will be difficult for you to understand our lecture. Because in the slide one, for example, we talked a lot about the basic stuff, like some rule, product rule, and all the meaning of this. So if you don't understand that, it will be very difficult for you actually to follow this course or to follow the lecture. Right? So slide one is a required knowledge, actually it's required knowledge to follow this course. But it doesn't mean that you have to, again, the focus of this course is not to test your basic knowledge, but to test whatever we discussed in class. You get what I mean here? Right? For example, I will not test you on specific questions about the product, for example. But I assume that you know about the product, but if you don't know the product, it will be very difficult to answer the question. And actually to follow our course. So you need to know some basic knowledge of the probability and statistics. Anyway, any other questions? Of course, the main thing is the material that we discussed in class. That's the main thing. But you need to know some deeper meaning of the topic that we discussed in the class from the textbook. Okay? Yeah. If there's any computation, well, to be honest with you, you are allowed to bring a calculator, basic calculator, but I don't think it's necessary. Yeah. Okay, any other questions? But who knows, just in case, just bring your calculator if you want.
Because you are allowed to bring a basic calculation here. Can you pencil? Okay, good question. My suggestion is not to use pencil. What happens is that the university department will scan your exam for a time. If if it's pencil, it will be difficult to scan.
Is it easy, for example, to writing the justification, I mean, when you want to raise?
Well, you can have a scratch sheet of paper on the booklet. So on the booklet is a space of blank space that you want to write directly. But there is no rule against pencil. So if you really have a urge to write with pencil, that it's okay because it's not mentioned in the rule. But my suggestion is to use pen because if it's pen, then it will be difficult for people to read. If it's written in pencil. Yes. It is recorded. It is recorded. It is recorded, right? Yeah, it is pause recording. So it is recorded. Yeah, thank you for reminding me that. Hopefully this recorded. It seems like it is recorded, but I cannot be sure 100%. Yeah, any other questions? Okay. All right, so if there's no question, yeah.
All this down that we can look to just know about the structure of the question and how they are testing.
Good question. That's a good question. I can give you some samples. Yeah, I will give you some samples so then you can know what kind of format the question will be. Yeah, I will provide you soon on the website. Any other question or suggestion? Okay. All right, so let's continue. So by the way, you can find on the lecture notes. So on the lecture note, you don't need to do the second derivative actually, because if you look at the lecture note or you look at textbook, there is already some definition of h. So h here is second derivative, as I mentioned, is second derivative there, right? So this is h, but h with further derivation is actually equals to phi transpose r multiplied by phi. Okay, so h is equally can be derived to phi transpose r phi when r is r and n is a diagonal matrix. So matrix R is a diagonal matrix. For this specific derivation, you can look at the lecture notes. So I will provide this to you, and you can also look at the textbook. Okay, so right. Let's move on now to, this is called MLE, right? So this is we done with MLE. So as you can see in the MLE, the final equation, MLE for classification, the final computation that you need to do for your programming is WK equal to WK minus 1 minus H inverse the first derivative of E of W. And this one can be written as phi matrix phi transpose matrix diagonal matrix R phi inverse phi transpose R Z, and Z is phi W. There is some small variable there, I will not explain here, but you can look at the lecture note, minus inverse y bar t bar. Right, so, and R is a diagonal matrix when R sigmoid n 1 minus sigmoid. So this is the equation that you have to implement in your code, or especially this one. Especially this one. Okay, so check the lecture note, check the textbook, and if you don't understand, please let me know. Okay, so that's MLE. Next will be NAP. NAP for classification. So NAP, we have to do the first step, which is posterior data modeling. If you want to write a posterior, we write posterior as P of W of is the noun is W bar, right? Given T bar. And this one is proportional to what? Probability of likelihood TW of given W bar multiplied by TW. So this is something that we want to use. And P of T bar given W bar equals to what? Anyone? This is the thing that we discussed just now, right? A few minutes ago. This one is a sum or product of n over n, P of Tn given W bar, right? This one is product of n. Yeah, so this one is not a lot, but we have to define with the fusion of two equations, right? The integration of two equations, which is yn t the power to Tn 1 minus 1n to 1 minus Tn. So that is the likelihood. So this one is the likelihood. That's the first term. The second term is P of W bar. So what is P of W bar? Yeah, the prior. How we can model the prior? What is the idea here? What is the problem of an NLE? The problem of an NLE is overfitting. Yeah, but why NLE is overfitting? What is the action that we do to make NLE overfit? To set n, right? N is the problem. We do not know n because n is a pi, right? How many complex your model you want, how much dimensionality that you want to use. You do not know how much dimensionality, how many dimensions that you use. And because you do not know what you do, to set n as high as possible. And that makes the classification become overfit. And the idea is what prior that we have to inject to reduce the dimensionality. Right? If you want to reduce the dimensionality, what does it mean by that? To kill off the dimensionality, to minimize the ability as much as you can. So basically, it's the same prior as in the regression that we want to set W as small as possible, if possible 0. So then we can kill off any dimensionality that is not necessary. Okay, so in that case, what is the function that I have to write? So we encourage W to be 0, or any Wn to be 0. Exactly. So the Gaussian of W bar with mean 0 and standard deviation of alpha I inverse for alpha I. Okay, so that's the idea. So in other words, we can just write Gaussian function of W. I can use this one is not given, but this one is n0 and 0. So you know that n0 equal to 0, as 0 is alpha I, or alpha inverse I. Any questions here? Okay, so now the posterior P of W posterior P of W given T bar proportional to this function here. Sum of n, 1n t to tn, 1 minus yn to 1 minus tn multiplied by Gaussian of W bar with mean of n0 and standard deviation of s0. This is the posterior data modeling. So this is your data modeling. Any questions so far? So again, here, if there's no question, then yes.
M0 will always be 0, right?
N0 is always
Why we
0.
don't put 0 instead?
Well, you can have 0 like even to be equal to 0. Yes, you can. Yeah, you can. Okay, so anyway, so this is the equation that we want to minimize. So we want to have a minimization. So the second step is the function. And the error function that we have here is W and AB equals to argmax W bar P of W given TW. Basically, we need to maximize that equation. Well, this derivation is the same as what we did previously, because the only new thing is that term, which is Gaussian function, right? There's nothing special there. We still need to do the minimization where TW bar equal to 0. But again, the same, in the previous one, we cannot have a closed form equation. We cannot have W equal to something. So for that case, but the good thing is that we know this equation, the first derivative of E with respect to W. And in that case, we also need to use Newton methods. And yeah, the rest will be the same. I don't want to give the derivation here, but you know the meaning of this. Right? I mean, you know how to do it already. Any questions here? Yes. Yeah. So good question. So what is the function? What function that we will have here, right? That's the question. Because this one is whatever that is a sigmoid function multiplied by sigmoid function, and this one is a Gaussian. So what kind of function based on this multiplication? Well, we do not know. Later we will discuss what that means. But for MEP, we don't have. Because in the end of the day, this is MEP. This is MEP. We don't care about the probability of the posterior. We just maximizing the probability of the likelihood and the probability of the prime. Right? In the same as in the previous discussion about regression, we actually don't really compute the probability of the posterior. We only maximize the likelihood and multiplied by the prime. Okay? But later on, when we discuss about Bayesian inference, full Bayesian inference, we have to have this one. And that one we can see what kind of function that we will have there. Yeah, good question. Yes. Yeah, you can choose anything. You can choose anything, yes. But for our discussion, let's stick with sigmoid because that will make the discussion easier. Yeah, another good question. Any other questions? Anyone? Good. All right, so that is MEP. We're done with this. And the next thing is full Bayesian classification. Oh, by the way, I guess the next assignment, we don't do NLE, we don't do NAT for the assignment. But we jump immediately to full Bayesian. So your next assignment is the full Bayesian. But saying that, this full Bayesian based on MLE and NLE. So in the end, you will do the same thing. So you have to do the Newton's methods and the yeah. So it will be learned from here for full Bayesian classification implementation. Okay, so in this case, we know the motivation, right? The motivation is that we are not like NLE because we don't like NLE because of what? Because overfitting. Well, overfitting is because of our act of defining n. If you don't know defining n, then you can simplify and then we can overfit to the training data. That's why we don't like NLE. And then why we don't like NLE? Exactly. NLE doesn't give you probability, doesn't give you uncertainty. It gives you the regularization. If you put estimation of W, but you do not know how good it is W, right? So that is the problem of MEP. So now we want to solve this uncertainty problem using Bayesian, full Bayesian inference. So basically, we want to solve P of W. We want to solve P of W given T bar equals to P of T bar given W. P of W divided by P T bar. So we learned in the past, why is it difficult? Why is it difficult? Yes, the denominator is make any is a big problem. Here is a big problem. Why is it a big problem? The integration is difficult and or yes, it's prohibitively expensive. Okay, so we want to. And the solution was what? What was the solution? Yeah, not two cases, but what is the simple solution? No, the essence of the solution that we had was what? There is two problems, right? With the P of T. One is not integrable, or many function is not integrable. The other is prohibitively expensive if you do it in discrete. In regression, which way that we solve? The first one or the second one? No. The first one. Exactly. So we solve the first one. We solve a special case of function, special function to solve that integration. And that special case is what? Assuming that the likelihood and the prior are Gaussian. If the likelihood and the prior are Gaussian, if the PT, W, and DW are both Gaussian, then we can do the integration. That's a good question. Now, right? Now, what we have, right? So now that's the question, what we have here. So likelihoods, let's look at the likelihood that we have. Is P of T given W equals to product of N sigmoid N Tn 1 minus sigmoid N power to 1 minus Tn. And the likelihood, the prior is P of W bar equals to Gaussian of W with mean of 0, or let's put it in more general, and 0, and 0, right? This one is definitely Gaussian, but how about this? Well, sigmoid multiplied by sigmoid. If Tn, if one of the Tn, because it's product here, in some n, it can be Tn equals to 1, but the other n, Tn equals to 0. So you have a multiplication of sigmoid and sigmoid. If you have only n equals to 1, then it's sigmoid, right? But it's impossible to have no classification. For classification, there are at least two to make it work. One is Tn equals to 1, the other is Tn equals to 0. It means that we have to multiply these two, which is multiplication of two sigmoid. So if the sigmoid for Tn equals to 1, for example, what kind of term or what kind of shape that you will have? It is this one, right? So you can draw this one here, Tn equals to 1, there, right? It is basically sigmoid. Is it understandable? So this one is basically a sigmoid function, something like that. Now, as I mentioned, with this, for example, this one is n equals to 1, but it's impossible to have one sample for classification. You have at least to have two samples, and n equals to 2 is when Tn equals to 0, because you cannot have Tn equals to 1, because otherwise you cannot do classification for two samples. For two samples, you can have Tn equal to 1 and the other Tn equal to 6. So if that's the case, what kind of shape that we have? Inverse of this, because it's 1 minus sigmoid. It will be the other way around. So it's inverse of n. Something like that. And you have product here. You have product operation there. So what kind of shape that you will have is product of this? It will look like Gaussian, right? It will give you something that look like Gaussian. It's not Gaussian. It's somehow like this kind of thing. It's not Gaussian, but it's somehow, look like Gaussian. Exactly, look like Gaussian. So what can we do then? It's not Gaussian, but look like Gaussian. Force it to be Gaussian. Force it to be Gaussian. It means that you do what is called approximation. You have to force it to approximate a Gaussian. So you force it, so then it can look like Gaussian. It's not really Gaussian, but you have to find a Gaussian that can somehow fit best into the function. Okay, so I repeat again because it's important. We have to find a Gaussian, the parameter of Gaussian that can best fit into this graph. So now how we can do this? Exactly. This is called Laplace approximation. So Laplace lived in 300 years ago, already thought about this. Okay. So it already proposed by Laplace at the time. Laplace approximation. Any questions up to this point? Again, the red line is not Gaussian. It just looks like Gaussian. And the green line is a Gaussian that approximates this red line. And our task is to find these Gaussian parameters. Okay, any questions here, anyone? Again, this Laplace approximation is something that we have to do for your assignment. So now, again, for Laplace approximation, it is Gaussian approximation, which is a Gaussian function. In Gaussian function, what are the important parameters? What are the parameters actually? And mean and standard deviation. So we have to find mean and standard deviation. No, that's something that's why I don't really like and zero equal to zero, because in this case it will evolve. Okay, so anyway, so it's likely because we are dealing with W bar, right? So this one is actually later on we try to find W bar. It's likely that it will not be standard deviation but covariance. Okay, so there are two steps here then. One is to find the mean, and the other is to find the covariance. Let me see. Okay, so if you have, we mentioned that you have an arbitrary function. Right? If you have arbitrary function, something like that, or maybe not that extreme, but something like this. And for this, what is the difference between mode and mean? For this blue graph here, what is the difference between mean and mode? Mode is what? What is the definition of mode? Most frequent, yes, most frequent. So this is the mode. And mean is what? You sum all this and divide it by the how many data that you have. And you do not know exactly, perhaps the mean can be here actually. The mean can be somewhere here. Okay, so the mean and mode for this kind of graph are different. Now, the idea of Gaussian is to assume the mode as the mean. The mode of this graph will be the mean of our Gaussian. So expectation-wise, is that it has to be like this. So the green line is our Gaussian approximated function in the form of Gaussian. So the blue line is the actual line, the actual curve, and the green line is the Gaussian approximation of that line. And in this case, the mode of that function becomes the mean of the Gaussian. So that's how we can get the mean of Gaussian. That's the question, how we can get the mode now, right? So the question is how we can get the mode. Okay, so finding the mode, let me see. Yeah, so the problem is that here, one of the property of the mode is what? How we can find the mode? The mode is this one, right? This one is the mode. And that one, you can have d of the blue line, assume that the blue line is at x. So we can have df of x with respect to dx equal to 0. That will be the property of this point there.
Even the second point.
Exactly, right? So even the second point here, it also has the fulfillment of that. Even this one, it also has that, right? So Now, if you look at this, it is a problem of what? We faced this problem before, right? When we are dealing with gradient descent, Newton methods. So that's why in this problem, to find the mode, we rely on the initial value. Okay, so the same as what we did in the gradient descent in Newton methods. In the Newton methods, recall the previous discussion here, this one, we also have the same problem. We rely on the initialization. So the same that we have to find the initialization so then we can find the proper global minimum. And the solution is exactly the same. We will use gradient Newton methods to find more. Okay, so keep that in mind because we will use that way of thinking in solving this problem here. But just for now, just assume that we can find the mode. Okay, and that mode is actually the same problem as the Newton's method that we have. Rely on the initialization value. Okay, so that's for the mean. That one is for the mean problem. The second problem is covariance. How we can get the covariance? Because the covariance is more difficult because we want to know what would be the best way of that so that it can fit best to the curve. Yeah, this is quite a long discussion, unfortunately. Let me try. Okay, so step 2 to find the covariance. Of fx. Again, fx is the function of this function, and we want to fit this one, so then we can have a good covariance of the Gaussian. And this one is fx, f of x. So let g of x equal to log of f of x. Okay, so I just have a simple trick by creating a new variable of gx, and g of x equal to log of fx, f of x. The problem here is that we want to approximate this line, right? We want to approximate this line. Let me think. Let's follow this one. So normally, if you want to find a fitting line or fitting function to a line, an approximation of a line, we use a Taylor expansion or Taylor series. Taylor series, the idea is that you want to have an expression that is simpler than the original function, and we use this simple expression as approximation. So basically what I want to say is that we can describe f of x, or in this case, g of x, in a Taylor expansion way. So in Taylor expansion, we have a first term, gx0. x0 is the value that you want to approximate. So in this case, if you want to approximate the green line, you need to have g of x around this one. So that's your g of x. So this one is x0, because you want to approximate at that point, right? So that's the definition of x0. And x0 in this case will be the mode. Yes, yes. So in this case, if you just want to have this expression that g of x equal to gx0, what kind of approximation that you will get? This one is a g of x0 because you know x0, then you know this location assume that is g of x, because g of x is the same as f of x. It's just a log of f of x. So in that case, what kind of approximation that you will get? Horizontal line, exactly. So you will only have a horizontal line So you will want an approximation. If you use this first term of cell expansion, okay, and doesn't look like the green line at all. It's just, it's just a single line, straight line. So let's expand further. The second term of the cell expansion is x minus x0 multiplied by t dx t of x given x equal to x0. So at that part, because we know this function, right? We know that we assume that we know the g of x. And x equal to x0. You know where it is. And then the first thing is that you do the derivative and then put x equal to x0. Right? In the end of the day, this one will become constant or scalar value. You will know that scalar value because you know Tx, T of x, and you know x. Right? So in the end, you have that one. In the end, it's also known, it's also scalar value. And x is this one, x is the x axis. So this looks like what kind of equation? This is a constant, C1, for example, plus x minus C2 is x0. The third term, the derivative, is giving you a scalar value of another constant on C3. What kind of function is this? It's a line function, right? It's a line function. So the second derivative or the second term plus the first term will give you something like maybe like this. That's the second approximation. It's better than the first one, but it's also not really look like the green one. Yes. The derivative is 0. It's not 0 because since you do the derivative, you do not know x. Yeah, so its maximum, the derivative, let me think. It's not the same line, I think.
Because we're doing the derivative at x all, so that's the mode, which is the horizontal line.
No, we do the derivative first. I'm not sure if that's true. I have to check that one. You do the derivative first, and then you put in the value of x0 after the derivative. Maybe it's yeah, I think it's 0. I think it's 0 because that is the peak. Yeah, so in that case, you're right. You're right. Maybe this one is the same as the first one. Okay. Yeah, that's the first one, same as the first one. That's good spot there. And then, because it's not really looking at the green point, then we increase further. X minus x0 squared divided by 2. And this is the second derivative. D of square t of x, dx squared, x equal to 0. And this one is not 0 because it's second derivative. And this one looks like what? The whole expression here now looks like what? It is plus x minus t2 squared multiplied by c4. It looks like what then? What kind of function is this? It's polynomial, but it's what is the degree of the polynomial? It is a curve with one inflection point, right? So it now looks like Gaussian, somehow like this.
C3 is 0, right?
Yeah, this one is 0. Yeah, but this one is not. It's still square, still curve, still quadratic function, right? So if you use the third order of cell expansion, then the approximation is almost like Gaussian. Can approximate the Gaussian thin line that we have here. Any questions here? Okay, so that's the idea why we use cell expansion. So let's look at at least further. So we know that as one of you mentioned that is equal to 0, right? This one is equal to 0. That term, the second term, is equal to 0. Now, if we continue with this, g of x equals to g x0 plus x minus x0 squared divided by 2, g of t x squared, t squared g of x equals to x0. Agree with this? All right. Now, we know that g of x is actually log f x. Then it is a log f of x0 plus x minus x0 squared divided by 2 t squared t x squared log f of x where g f of x where x equals to x0. Agree with this? Because that's the definition of g of x. Now let a equals to this one. So a is minus that term. So a is minus t, sorry, not that term, but with t, this term. Tx squared log f of x, where x equals to x0. Okay, so it's just define that term as a. If you define that as a, then log f of x equal to log f of x0 minus a divided by 2 x minus x0 squared. Agree with this? Right? Because we know that the second derivative is a constant, and the constant I put it as a. Now, if you want to have f of x equals to what then? So the first term become what? Become f of x0, because that's log, and minus become what? Minus something then. It become exponential function of minus a divided by 2 x minus x0 squared. Agree with this? Agree, anyone? Agree, right? Because if you put log, then the exponential function will be gone, and that will be minus. So now, what does this function look like? It's a Gaussian function. It's a Gaussian function. So what was the purpose? To find our purpose is to find the, yes, in this case, the step 2 is focused on finding the standard deviation. So where is the standard deviation? So where is the standard deviation here? Exactly. Standard deviation is represented by A. Well, it's something to do with A. So the standard deviation or sigma is 1 over A. Yeah, square root of A. It is square here. Then it is 1 over A. Right? So this is the answer. The log is trying to make the function is simpler. If you log exponential function, you have this curve function, the quadratic function. That's why we need to have a log here. But anyway, so that's how we can get the deviation. Any questions here? Okay,
So if we want to get the actual standard deviation, we have to solve the second derivative of log 50.
and that one is Bayesian method. Right, that one is Bayesian method. And you will use Bayesian method in solving the standard deviation. And that will be discussed further next week. Yeah, any question, anyone? Yes. We are approximating the Wallace radical question. Yes. The question was whether we are approximating the likelihood of the Gaussian. Well, I can tell you that it seems to be like that. But later on, we know that we are approximating the multiplication of likelihood and phi. Because if your likelihood is look like Gaussian and your phi is Gaussian, if you do the multiplication of something look Gaussian and Gaussian, what do you get? Something look like Gaussian. You know what I mean? So likelihood is look like Gaussian, phi is Gaussian, you multiply them, what the things that you get will look like Gaussian. And this look like Gaussian of the multiplication of likelihood and phi that we will try to approximate. That will be discussed further next week. Good question. Any other questions? Oh, we haven't discussed anything about solving the problem because we just try to understand how to find or how to do the approximation with the approximation method. Yes. Any other questions? Okay, so if there's no question, that's all today. Thank you, and I will see you next week. Yeah.